or Lewis.
Cool. All right. Now we'll leave it 1 more minute for all of those who are still, you know, doing whatever they do. Yes, having coffee. A little late for coffee on this side of the world.
Yeah. JJ, ready to go?
Yep, I'm here.
Cool. All right. Let's kick it off then. Hi everyone. I didn't introduce myself earlier, but I am Lewis. For those who I haven't met, with Cross Lake working on the OSS team, and we have JJ.
Yep. Hi guys. I think we probably would have met in last PI convening, but I'm JJ. I'm a software engineer at Google, and I'm working with Lewis and a whole bunch of other folks on this third-party payment initiation project.
All right, let's kick it off. I think we got the first few. So we've done a bit of a background before, so I'm just kind of skip over a bit of the background. But in general, the goal is to enable third-party payment initiation within Mojaloop. So at the moment, funds get sent from a source account, a source DFSB account, to a destination DFSB account. And we want to have the ability to have another service, another utility called a PISP, Payment Initiation Service Provider, to initiate those accounts on behalf of a user. So this presentation, we're just going to be kind of updating everyone on our progress, talking about some of the decisions we made. We're going to go, the account linking design, which we'll kind of come to how we've separated the design elements out, has really evolved a lot, and we're really happy with it and very proud of it. So we're going to be sharing that with you. And then kind of our plans for PI 11, and we have a little special one more thing. So when Apple does their one more thing announcements, they don't put it on the first slide, but we thought we'd do that here. So cool. So background, the term PISP comes from the PSD2 European Payment Service Directive. And in Mojaloop, we're calling a PISP like a new type of participant. So traditionally, participants are DFSPs. And as with what Michael was talking about yesterday with the cross-network stuff, they have a CNP, cross-network provider, which is a role. A PISP could be another role inside of Mojaloop, which is a participant. It has a few funny quirks to it. So I'm going to leave these in. You guys can look at these later if you want more background, but we've covered them before. So coming to our past objectives from PI 10, we kind of had two main objectives. One of them was an end-to-end PISP transfer flow. So we wanted to see kind of a mocked out flow for some bits and pieces, but to see everything kind of working all together. Looking just at the happy path, so no error scenarios, just making things kind of nice and easy on the developers. And secondly, we wanted this well-defined relationship between a user, their PISP, and their DFSP. So actually, I will come back to this slide just momentarily to talk about a user, Aisha here, their DFSP over here, which exchanges funds on the switch, the PISP, which has a smartphone app, which allows Aisha to send funds from their DFSP. So just so we're all on the same page. So how do we do? Okay, I think our first objective maybe should have, we very much underestimated the amount of work this was going to be, and that's all part of learning. And we've got some stuff to share about our next PI plan or what we're thinking of doing. So it'll be good to gather some kind of input. So yeah, that's still ongoing. We're getting pretty close. We'll show you how close later. Second objective is completed, and that is what we'll be talking about with the account linking designs, as we said. We also had a couple secondary objectives that kind of came out of the our sprint planning or our PI planning last time. The third one, I know I owe Ed and Istvan an email because I know that these guys have been working on it, so they might have stuff that they'd like to kind of add to this, so we can kind of continue the discussion afterwards. I know they've been thinking about the onboarding and the kind of API gateway component of this, especially around OAuth, and what that flow for the web sign up looks like. And then with number 4, we actually didn't really know how far we'd get along this line, but because we've had some wonderful interns from a little company called Google join us, we have really managed to accelerate these efforts. So it's really exciting to see a bunch of new, young, excited engineers joining the team. So it's great, really great. Cool. So moving on, some of the key decisions we've made, and these have been ratified with the design authority and have been brought to the attention of the CCB, if I'm not mistaken. Michael can correct me if I'm wrong. What we kind of figured out as we were designing this, we realized that it doesn't really make sense to, the initial design was to have the PISP stuff be kind of just a few little add-ons to the existing Mojaloop API, FSP-OP API. And as we kind of continue to work on the design, we really realized that this should be a separate thing. The FSP-OP API is really about getting money from A to B, exchanging funds and doing clearing between two different parties. And while there is support for stuff like transaction requests with merchant request to pay use cases, it didn't really feel right to end up putting maybe doubling the length or even more than doubling the length of the API specification to add in some of these PISP use cases, which some DFSPs might not even want. So, and it would create kind of an extra burden to implement a bunch of these features. And kind of, so we kind of decided to separate these things out between what we're calling a new third-party API. And we didn't call it the PISP API, we call it third-party API because we thought there might be other things in the future that could qualify as third-party things. And then from there, we've actually divided it even further, because if you think about supporting PISP use cases, there's two sides to this. And one is the API that the PISP needs to implement, and the other one is the API that the DFSP wants to implement in order to allow PISP to happen. This was also a consideration was around security levels and enforcing different security at the API gateway kind of per API. Additionally, we have designed a new auth service which handles the FIDO credential registration. We'll be kind of talking about what that auth service does in just a second. But just know that we've designed this and we're currently implementing it. And we have this concept of a consent object, which is a resource which fulfills that second objective, what you said, which kind of represents a relationship of trust between a user, DFSP, and their PISP. And it has a special FIDO public key credential, which is tied to a private key that lives on the user's device to tie it all together with special FIDO secret sauce. Well, it's not that secret. So the main thing here is that we've designed it so that the hub could operate the auth service on the behalf of DFSPs, but they could also operate their own. And that was a key part of our design because we didn't really know, we wanted it to be easy to implement for DFSPs, but we also wanted to give them maximum flexibility. So I'm going to hand over to JJ now to talk us through the account linking, which we have some very long sequence diagrams. So let's switch over to GitHub. While I do that, JJ, maybe you can give us a little intro.
Yeah, so thanks, Lewis. The basic gist here is we really want to end up with this consent object at the end. The whole point of account linking, and this is the part that's often ignored when we're designing, like in the original design from a colleague of mine at Google, it completely just omitted the account linking flows. And so it's important to remember that account linking's job is to establish mutual trust between these three parties, which is a user, a DFSP, and the PISP, the payment initiator. Ultimately to the point where a DFSP, when it is instructed by the PISP to send some money, they can go, okay, well, I trust you because that consent that, that we established before has a credential, and therefore I can verify that you digitally signed this with that same credential. And so if you can zoom in a smidge more, Lewis.
Yeah, sure.
Not
that one.
Oh, no, that's too far.
Yeah. Very hard.
Right. So the first step we're just going to kind of gloss over here, just because it we don't need to spend too much time on this, is pre-linking, which is sort of the PISP is sort of asking the switch who's available for me to link with, which DFSPs support third-party initiated transactions. And it'll respond with who's available. We don't expect this to change very often, but it's worth having in there. So if we continue on down, so in the discovery phase, what's happening is this is before anyone has trusted anyone at all. The user has chosen that their DFSP is DFSP A, let's call it wallet A. And so they go, okay, well, how do you log in with wallet A? Because we need to know which source accounts are available to link with. And so you pass in this get parties request using a special opaque identifier type. And then you provide just the username that is, the one that you use with this particular DFSP, in this case, wallet A. And in there, you're specifying exactly where the get parties request needs to be routed to. So unlike a traditional get parties request, there is no ALS request right now, because you've already, what the result of that ALS lookup will be, because this is an identifier that is only meaningful to that specific DFSP. So what we do is we provide that initially, and the switch passes it along. And what the DFSP needs to respond with is not just, yes, I speak for this person, which is what we previously saw, but it needs to say, okay, yes, I speak for this person with this particular identifier, but also here are the source accounts that are available to be linked with for that particular person. And also the currencies, because we're thinking forward about cross-border and things like that. But most importantly, the identifier here is not your traditional bank account number or anything like that. The number here should be only meaningful in the context of this particular PISP for some well-defined limit of time and things like that. In other words, if this identifier gets leaked, it's not a big deal. It needs to not be a big deal because it should only be usable by this particular PISP and for this particular user to then establish trust with. And they will authenticate later, but this is just an arbitrary source of funds identifier. So at the end of the discovery phase, the PISP now has a list of the available source accounts to link with. So after this, we know what we want to link with, right? We know that the DFSP speaks for us. We know that the accounts available have the right currencies, all that stuff. Now our job is to go, I need to establish consent. So as I said at the beginning, the end goal is that we have a consent object that represent this link and mutual trust. So we need to get that. So what we do is we create a consent request object. We pass in a client-side generated identifier. We pass in the initiator ID, which is us. And then we provide a source account identifier and a list of scopes. So what this is saying is, not only do I want the specific source account, but I also want to be able to do these things on that source account. And in this case, we've listed transfer money and retrieve balance. The balance we're not actually going to use for any nearby time frame, but the transfer is obviously quite important. The other thing to keep in mind is if we're using the web flow, as you'll see in a moment, we will get redirected to the DFSP's endpoint. And so it is possible for them to augment this list of source accounts, adding, removing, changing scopes, things like that. So think of this as you chose to link with the savings account, but after you actually log in, it gives you the option to go, oh, wait, I meant my checking account. And they could check one box, uncheck another. And before you know it, you have a consent with a different source account ID. Again, not a problem, because ultimately our goal is just a consent that says this. So the next few stages here are basically the request being passed along, and then all the way down in request 5, this is request consent. The DFSP provides back a URL that says, here's how you can go prove that, or have your user prove that they are them. And so what they do is we just redirect this back. We send this back to the PISP, and the PISP's job is to get the user to go there and do all of the auth. Right, so we would redirect a user to that exact point. So that's in request 7 is what's happening there. So now if we jump along to this, this is the, we're going to skip the OTP for the sake of time. We're running a little behind here. But the point is we're going to redirect someone there for them to do a whole login thing. So now the user has logged in. So as you can see in this yellow box, it's a little small, but they go through the web auth part, right? That's where you log in, type in your password, however you authenticate with this DFSP. And the end result is, after you're done with this process, the DFSP is going to redirect you back to the app. And by doing that, it'll also include some sort of secret. It might be a very long token string. It could be anything, but it's a secret that the DFSP is going to give you, so that you can then give it to the PISP, so that the PISP can then give it back to them. It's sort of handing around this top secret envelope. And so when the DFSP gets it back unaltered, it knows, okay, cool, because I gave this to the user. So if it's making it back to me from you, that means the user must trust you. So everyone's passing along this secret. So we update the consent request with the secret. It gets passed along all the way in auth 3, all the way back to the DFSP. And then the DFSP is able to verify that, to check that that this is exactly what they were given. So at this point, we know this is all good. After that, the DFSP knows everything's fine, and from here on out, this is just creating the consent. So the DFSP says, hey, I'm creating this consent. I have authorization to do it. Here's what it is. And so now we inform everybody about this consent, and you'll notice a new entrant into the thing. It's the auth service in the bottom right. We have now told the auth service, hey, here is a consent that I need to have you manage. And now this might be run by the DFSP. It might be run by the switch. It's sort of up in the air. Anyone can do anything. I think by default we'll have it run by the switch. So at this point, the only thing that's missing here is the set of credentials that everyone trusts, because now we know that the DFSP trusts the user and the PISP, but how do they prove that they are them? So at this point, if you scroll all the way down, this is just the FIDO flow. The PISP requests a challenge to then be signed. So it says, hey, please generate me a challenge, and we update the consent with that challenge. Then credentials 4 is where we update it with the challenge. Sorry, 6, not 4. Then we go down, pass that along. Keeps going down to credential 8. Are you frozen? Oh, there you go. Okay. So now the PISP has it. And here at this point, we go all the way down. The user just signs the credential and says, by the way, here's the public key I used to do that. Sorry, signs the challenge and says, here's the public key that I used to do that. So you see those 3 new fields. And from here on out, it's basically verifying that the signature is okay, and then telling everybody. That's in credential 14. The auth service verifies that the credential is acceptable. And from there on out, it's just notifying everyone that the credential exists. At this point, and I'm sorry I moved quickly there, I just noticed the time. At this point, we know that the credential is stored appropriately and the consent is fully formed. So it has the various people involved, it has the source accounts and the actions that you can perform on those source accounts, and it has a credential that everybody can honor and know. If anything is signed by this credential and they reference this consent ID, then all I have to do is check that the funds are coming from this account and that it says that I'm allowed to transfer. At that point, I know everyone agreed to these terms and we are all good. So that's sort of the end of linking. We've reached the point of here is a consent that shows all this stuff. And so that took us quite a few iterations to get through. We had it most of the way there at the last convening, but we had to round out a few things later on. So again, apologies for the absurdly long sequence diagrams. And now we can continue on.
You sure can. We've only got a few minutes, so we can leave the plan for PI11 to our work stream, but I do want to just say very briefly, we want to have the end-to-end transaction flow. I know we said it last time. I sound like a father who's like, next time I'll come to the ball game, son. But we will have it done next time. Transfers scheme adapter. So we're kind of focusing our efforts in on the center and then working our way out from the scheme adapter. And we didn't really do that last time. I think that was something that we could have done better. Fully implemented auth service with integration tests, and third-party API adapter, implement account linking calls. And just to, if you want to look at the slides later, I made this really pretty picture, so please look at it. It's really pretty. Yeah, so this is where we're at now of all of our inbound and outbound calls. And here's where we're going to be by the end of the PI, very green. And this is for the transfers. And next one is kind of account linking. So we've, like I said, we've divided it up into 2. Account linking, we're going to have, this is where we're currently at, so not very far. And this is where we're going to be. So all of the stuff in the center and all the auth service stuff done. JJ, you have a couple minutes to talk through the demo app. I really do want to highlight this because this is cool.
Super zippy. So we, as Google, as Lou said, we at Google had quite an influx of interns because we needed folks to work on open source projects. So you might have missed it in a previous slide, but our design was originally to have the OSS service mocked out. And because of these available interns, they were able to get most of the way done on the OSS service being actually functional. One of the other projects, though, was basically a demo app that uses this payment initiation API directly, not through the scheme adapter, actually, and demos that these things work. So you can see some screenshots here, right? This is just logging in with a Google account. We just chose that because it's easy to do with Firebase, and we're using Firebase under the hood. You can set up all of your different accounts and things like that. And next one, Lewis.
Yep.
There you go. And, send money, obviously, so you choose where it's coming from, the different source account IDs, enter the amount, and then, use the FIDO to actually do the transaction to sign the quotation that would come through. Everything is currently pretty far mocked out. We have a few things that are relatively real, as in they talk through Firebase to an actual backend server. And that backend server is designed to talk to Mojaloop, but we haven't set up a full test environment for this just yet. We're exploring how to do that. So with our very last few seconds, we can talk about it there. Just show the pretty. What did Lewis?
Humans of the PISP workstream. I just want to say thank you to everyone. There's a couple people who aren't on here that maybe should be. I know we have a new intern that joined today, so welcome.
Yes,
you're not on here. But I just want to say thank you to everyone who's helped out on this and your very, very hard work. We really appreciate it, and we're lucky that we get to present what you've all been doing while we twiddle our thumbs sometimes, waiting for you to do the work. So thank you very much. And we'll leave it there.
Thanks so much,
questions.
Yep. I don't see any questions in the chat, but thank you so much, Lewis and JJ. If you've got any questions or want to continue the conversation, there's a link there to the session discussion thread on Discourse. Please take a look at that. I will pass it on to Sam, Michael, Vijay, and Georgi to talk about the testing toolkit and CCB updates.
Great, and just as they're getting set up, I wanted to make a quick point here. There is a PISP workstream session. When is that scheduled for, Simeon? I think it's day 5
on Friday. Yeah, if it gets enough votes, there'll be a session. That's the.
If it gets enough votes, okay. So we need to get the everyone should show up.
Yeah, we need to whip the vote out here.
Yes, get the vote out. Anyway,
Exactly.
my point was only that we really do want to get some participation here. It's really great to see the progress on this. The good news about making progress this quickly is that we get a chance to really interact with something directly. The bad news is that a lot of people didn't get to interact with it as it was coming together. So there may be some feedback that we can get. We want to get that in as soon as we can to be sure that this thing really did get some eyeballs on it. Not that it hasn't had a lot of rigorous work done by the Google team. I'm really glad to see that. But we just want to make sure that, especially from some of the diverse inputs we have here, that folks can think about what would I do with this in my market, or how would I use this if I'm a merchant, or some of these other cases we've talked about, specifically with Snap, as you heard perhaps on yesterday's session, how they're thinking about using this in a very unique way. It would be very interesting to see how that would come together. I would actually like to see if there's a chance for us to fit it into the agenda by maybe shuffling some things around to go through a little bit more depth on this, either through the demo side or through some of we talked about the consent object and the transfer authorization flows. I think it would be worthwhile. So if we can do that during the work stream session, that's awesome. That's probably the best way to do it. But if there's also a chance for us to do this during a wrap-up session, that would be good too. Anyway, I will shut up and give it over to Michael, etc.
Thanks, Mela.
Thanks. Yeah, I'll see what we can do within the schedule. Sam?
Thank you, Miller. Thank you, Simeon. Thanks, everyone. That was a great PISP presentation. So we're back to the Mojaloop core team updates. This time focusing on the CCB and the toolkit. We have Vijay and Georgi on the call as well, and Michael, Matt, I think, can take any questions as relevant. Thanks everyone. So the change control board, the purpose and the goal of the change control board was to maintain the Mojaloop FSP interoperability API, make sure that the changes are vetted and thoroughly reviewed before being accepted, and making sure that the API was in good shape. We have the founding members, essentially the authors of the API, from 4 of the teams: Ericsson, Huawei, Mahindra Comviva, and Telipin, part of the members. Apart from that, we have 2 members, Matt and Miller, of course, from the foundation, who are the initial sponsors of the project. Michael and I are on the CCB as well as non-voting members. Michael is the chair, and then we have 2 of our implementation partners, Mawali and Telipin, on there as well. John, Mark, and Muta from representing Mawali and BOT respectively. Typically, we meet bi-weekly. There is a call, but most of the actual work is happening on GitHub issues. So we have a Mojaloop specification repository. We have the official documentation set that's available there. We have the swaggers available there, and all the issues are submitted either as change requests or solution proposals. And currently, Miller showed a good timeline on day 1 for those of you who are there, but this is something focusing on the specification side as such. So we saw the beginning in 2016 towards the end of the year when it was formed, and then we had the Mojaloop branding done in 2017 in Toronto, in October. And then we had the official documentation set for specification 1.0 released in March of 2018. And now in May, we had the 1.1 published. Over the course of time, there were many change requests and solution proposals. Only the non-breaking changes made it to the list. We do have some accepted items in line for 2.0. So 2.0 will be where we'll have breaking changes. So we'll have the PISP, whatever is applicable to this spec, and also some cross-network currency that are applicable to this. They'll come in that as well. So we covered this. Changes are in pipeline for version 2.0. And there is another proposal which may actually revamp how we are looking at things. So currently, the Mojaloop Foundation, the Gates Foundation, and the Change Control Board are working to streamline the various groups that are looking at different APIs. And I think in this PI, in the upcoming PI, we may have some clarity on how things will look like for the long term. With that, I will go into the version 1.1, what the changes were made. So there is an issue here that is listed. It's a tracking issue. It contains all the changes that are included in the version 1.1. So the ones that are highlighted in, I would say, light blue for lack of a color distinction, are covered already in the core team updates, where we said that we've adopted and made changes for these. The rest are mostly bugs or omissions or description added to the text to add more clarity and remove ambiguity. So there are 7 changes in total.
Sam, quickly before you move on, I just want to make one point here, which is that from the point of view of the FSP IOP API version 1.1, item D there, clarifying the usage of aborted, would not be considered a breaking change from the perspective of the specification itself. However, from an implementer who was using the actual aborted state, it is a breaking change, because that's going to get silently ignored now. So I think this goes back to the point Mawali raised, which is very small changes which are not considered breaking could actually be breaking changes. Yes. And so I think you have the right picture, though, is to say these are not breaking changes to the API specification itself. But this is exactly the kind of thing that Mawali would say, but you need to alert us of something that we might experience as a breaking change.
Yes.
And I don't have a good answer for that, is because people should have been doing the right thing to begin with, but the specification was perhaps ambiguous in the way that it made that requirement, it stated that requirement. Anyway, just thank you.
I didn't go through that, didn't want to dwell on it, but I wanted to actually walk through this Helm release. So this is the version 10.4.0 release that included those changes from version 1.1. And this also touches on the point that Pierre mentioned about. So we are writing blogs now, holding like different sessions. I think we've talked about this in 10 different meetings. I don't want to go through all the sections here for time's sake, but you'll see the maintenance updates, new features, bug fixes. And there is a section there at the end which says breaking changes. These are not breaking changes in the API, but it will break the tests and functionality. And there we've listed this out, like we're calling this out, what's happening with the aborted state and other implications.
That's great. Perfect. Thank you, Sen.
Thank you. I'll go back to the presentation. Yes, again, that's valid. And in line with what you and Pierre said, we'll make sure we're evangelizing and talking about this in more places. And Simeon also had a blog recently on the Mojaloop Foundation where we're talking about things like this. So we'll improve on that. Thank you. With that, we'll go into the testing toolkit. So Michael, please add anything. Feel free to add anything if you see I've omitted. The initial goals of the toolkit was to give a tool that can test any FSP interoperability API implementation. That was the goal we started out with, and that it was simple to use, not just the QA teams, but we'll have a product and business users being able to use this. And we wanted this to support different versions of the API. We don't want this to go obsolete or out of date once we have a new version of the API. We want it to be highly configurable and also support both inbound and outbound requests. Miller, did you have a question or someone? Okay. All right. So what is the testing toolkit doing? What is it? Again, there's one other aspect that was brought up in the Mojaloop feedback about the onboarding time taking longer than desirable. So the toolkit, we want to give a capability for scaling where schemes don't have to spend too much time, but this offloads some of the responsibility where FSPs themselves are able to self-test or self-certify. So the DFSP implementation can take a testing toolkit. It can just be on a developer machine, it can be on a cluster, on a virtual machine anywhere, and then they can test both sides of their implementation, the inbound side, the inbound and outbound requests. And the same thing for the switch as well. Along the way, what we thought was the toolkit can be used with any API. So if you are testing any FSP IOP API implementation, why not test the hubs also? So now we can use it for hub implementations as well, both inbound and outbound side. So let's say in the case of Mobile or Tips, they can use it to test their own implementation, but also they can just add a couple of rules to customize it and then give it to their DFSPs or FSPs and have them test. So that way, by the time they want to integrate with the switch or the scheme, they're already conforming to the spec. They already abide by the rules, follow the data model, follow the rules of security like TLS, NTLS, and JWS, because those are present in the toolkit as well. Where does it fit? So this again shows what we discussed so far. The testing toolkit can test a hub. Like here you see on the left side, we have the toolkit and it can test a switch implementation. And by playing the pay FSP side, they can test the outbound functionality of a hub. And there is a mode where we have a pair FSP, an FSP that wants to onboard with a scheme. And then the toolkit can play both sides, the hub plus the pay FSP side, so that they can test their implementation end to end. It also helps that the Mojaloop API, as James likes to say, is symmetric. And so it helps us like abstract this part. We'll quickly go over the tools that are available right now and then focus on what we did in PI10. We have a user interface as you saw already, and we want this to be usable by the QA teams, product teams, and business teams across. By making available all the features that are needed to add assertions and rules and validate data, I think this is made possible. We also have version validation and negotiation. Apart from the basic features of schema validation, we can write rules for callback generation, validation. We'll also see some of these where we can see the reports that are generated based on test sets. And item number 5 is what I covered earlier, the support for multiple APIs. For example, we can support the FSP interoperability API, settlement API, and admin or the operations API at the same time. This way, it acts as a switch itself. So we can use it to test a switch implementation, or we can have the toolkit act as a hub by itself. Then we have support for JWS and MTLS. We have a command line interface which can be used for like DevOps, or if there is an infrastructure as a code script that spins up a cluster or clusters and then deploys Mojaloop. As a last step, potentially it can use the toolkit to validate the deployment by using the command line. We can automate that. We can also automate it for cron jobs and in CI/CD jobs as well, where we have a toolkit image running tests on a given image with the changes. Also, it's very lightweight so far. We've been able to keep it lightweight and simple to use. All the items present here, I think we will see demo in some form. I've touched on this. I don't want to go into too much detail, but a few things to highlight is we have the basic hosting capability. And I don't know for whoever paid attention last time, but at the time it was mostly a POC that was standardized. So we had like 40% test coverage, but now we have 98% or more coverage. So credit to the team on that. The demo that we saw earlier, I showed for the core team on the assert accented characters, was actually on a hosted version where we had a Helm chart for the toolkit, and it is deployed on our AWS dev environment. All right, with that, I'll pass on to Vijay, who I'm sure is ready for the demo and the next topics.
Hi guys, I'm Vijay Kumar. I'm going to show you the new improvements in the testing toolkit. I will show the only new improvements. I will not go through the basics of the testing toolkit. If somebody is new to testing toolkit, they can go to GitHub repository of ML testing toolkit. There we added so much content to the documentation in this PI. So let me share my screen. Can you see my screen?
Yes, I can see.
Okay. So to start with, we added support for all the resources in the FSPOP version 1.0. So you can see the list of resources here. These are the pre-populated rules for all the resources in the FSPOP 1.0. And also we added support for FSPOP 1.1 recently. If someone wants, they can go to create rule, and there you can see both versions. And then the next item is we created Helm chart for the testing toolkit. So the URL you can see here is hosted on our dev environment using the new Helm chart. So by using this portal, we can test our Dev 1 and Dev 2 environments, which we usually use to test our collections. So let's go to the test case execution. Yeah, here we added support for Hub. We created almost all the use cases to test the Hub implementation based on the Postman Golden Path collection. So you can see all the test cases here. This is for Hub, and these are for DFSP. And also we have one for provisioning to provision the new testing toolkit DFSP as a DFSP. So first we need to run this provisioning collection, and then I already ran that. So we can select all to run all the tests. I will select first two, and the environment here. This is the environment file of Dev 1, which contains proper endpoints to test the Dev 1. You can see all the test cases are loaded here on the left-hand side. Okay, I'm going to send this. So here all the test cases are executing one by one and waiting for the callbacks and replacing the proper values in the next request. Here we did many improvements in this area. Yeah, so you can find the new button here, download report. So we can download the report in either JSON or HTML format. So the report is downloaded. This is the basic format of the report. This is summary page where you can see the total time and the success and failure cases. And if you go into details, then here you can see almost everything like requests, callbacks. For example, for the P2P transfer, for send code, we have request headers, request body, and a call command, callback headers, and callback body here. So this is the HTML report. Let's go into more detail. Let's open the second test case. Yeah, here for the first thing you can observe is the call command. This is the call output of the actual request sent by testing tool. So you can copy this command and execute in your terminal, or you can import this call command into the Postman to simulate the exactly same request. This is for debugging purpose. And here you can notice a new tab, scripts. We enabled scripting capability here, like as in Postman, and we use the Postman sandbox library for executing tests. Through this scripting, we can write complex tests and assertions. So like sending third-party HTTP requests and setting some environment variables and accessing those in the later requests, like that. We added some console logs and environment for debugging purpose. We can have environment state at this particular point of time, at each request. Okay, and yeah, we have a import curl option here. From the Postman, you can export a single request as a curl command. So you can export that and import here. It will populate headers and body from that call command automatically. These are the main improvements in the test case execution. Okay, so before going to the next section, which is hosting capability, any questions so far? And Sam, do you have any input?
Yeah, I think we're good. Yeah, let's go to that.
Okay. Okay, so for explaining hosting capability, let me go through a slide.
Do you want me to present?
Yeah. Okay, so till now, a DFSP need to download the testing toolkit and to test their implementation. Suppose the idea is if a scheme hosts this solution, testing toolkit solution, and give credentials to DFSP, so that the DFSP can send requests and get callbacks by configuring their endpoints like that, endpoints and some certificates, so that multiple DFSPs can send requests to the same instance, hosted instance. For achieving this, we have to take care of multiple things. In the testing toolkit, we need to separate we need to implement the authentication and separate the TLS and JWS certificates, and also rules, settings, endpoints, logs, and reports. So we did some of these things as an initial step. We implemented the authentication and took care of the certificates DFSP wise. We use it connection manager. So DFSP will be provided access to the connection manager. In that, he need to upload the JWS and TLS certificates, and also they can configure their endpoints in that portal. Okay, let's see that. This is the testing toolkit. Hosting capability enabled. So that's why we got this login page. I'm logging in as a user DFSP1. Let's go to monitoring phase. This is the monitoring phase for monitoring inbound requests. And also, this is the interface for connection manager. So initially, the DFSP need to log into this portal and upload his certificates. And also, he need to configure the endpoint. This is the endpoint of user DFSP1. And some certificates like TLS client certificates, server certificates, and also the JWS. So I already pre-configured all these things. So let's send a transfer as a user DFSP1. I'm using Mojaloop simulator as a DFSP implementation. This is the interface. You can see the host name here. This is hosted in some other instance. So I'm going to send a transfer as a user DFSP1 to the testing tool. Yeah, I got the transfer successful, and here we got request from user DFSP1. If you observe a request here, the JWS signature is validated. So we made changes to maintain JWS certificates, DFSP wise, and also the TLS certificates. By the way, all this communication went through TLS, mutual TLS, and the JWS enabled. So the testing toolkit can now take care of the TLS client certificates based on the requests from the DFSP. So yeah, this is about the hosting capability so far. The next roadmap item here is we need to separate the rules and settings, user settings and rules. We need to maintain DFSP wise. And also the logs. We need to store the logs and cater them to the target DFSP. Yeah, so this is about the hosting capability. Any questions?
Yeah, let's keep going.
Okay, then Georgi is going to explain about the command line tool and some other improvements in the testing toolkit. Yeah, Georgi, you can go ahead.
Yeah, hi, my name is Georgi. So I will show a demo of some of the features that we implemented this PI. Let me share my screen. Okay, so I will start with the command line tool. So first I will execute the help screen. Here you can find some basic information, some details like default values and options. And here you can execute the monitoring for the dev environment. So now we are listening on events on this host, to this URL. And now I will execute with -e. I will pass the input template with the predefined test cases. With -e, we are passing the environment. And with -u, we can pass the URL. So now the test case is executed. So in the end, we can find the summary, the total assertion, how the test assertion passed, how many requests we have, test cases, and so on. And in the end, we generate a report similar to the one that Vijay showed earlier with the with the dash report format. We can specify different formats like HTML and generate HTML report. And also we are returning the execute zero if everything is fine, and 1 if we have any failures, so we can use it in automation. So that is for the CLI. Cool. Okay, then let me open the dev environment. And now I'm going to show the caching functionality. So I will execute the PTP path, and I already configured a limit of 200 for the total amount of money that can receive. So if I execute this request 2 times, and then the 3rd time should fail because we already reached the limit. So here we predefine some rules, and also the validation rule that will execute the error callback. So let me execute the request 3 times. So you can see that this one failed, and the response is with the error code 100, sorry. Okay, then here you can see some of the, sorry.
Georgi, I think the scripts are in transfers role, right?
Oh, really? I was just thinking so. Okay. Oh, yeah. So we can here see the environment, and that the limit is already reached. So, and yeah, this PI we also implemented the prioritizing rules. So now this one is with higher priority, and we will return the error code 3100, for example. And the next one should return the 5100. So I will change the priority, apply it, and I will execute. Sorry. So yeah, now we receive the next callback. So yeah, we are already, so that's more or less.
All right. Thanks, Georgi. Vijay, is there anything you want to show, or can I start sharing?
Yeah, I just want to show next slide.
Yeah, go ahead.
Okay, so Georgi explained about the command line tool. So by using this tool, we can integrate the testing toolkit in CI/CD automation. So when the code changes in a repository, the CI/CD tool need to download those changes, build and run the Docker image of the DFSP implementation. Then it should run the TTK, testing toolkit instance, and configure both endpoints of the DFSP implementation and the testing toolkit to point each other. And from the command line tool, we can send test cases to the testing toolkit service so that we can get a consolidated report. So this is an idea to integrate the testing toolkit in the CI/CD automation. Yeah, but I'm not a DevOps expert, obviously. So yeah, this is just to give an idea.
Yeah, this would definitely be lightweight than building up a whole Mojaloop end-to-end solution. So yeah, we can look at that. Thanks, Vijay.
Thanks, guys.
Okay, we do have some roadmap items we wanted to go through, but we can go through those in the breakout session if the toolkit gets prioritized as one of the items. Thanks, Amy.
Thanks, Sam and team. We're down to the last session, which is the Mifos lab update. Edward, Cable, Istvan, Molnar, and Kristof, Jozsa. You guys ready to go?
Yeah, we're ready, Simeon. Istvan's going to share the slides. So.
Sure,
Yep.
Just a quick one before you begin. Right after this call, we will upgrade everyone to panelist mode, and we'll take a screening. So be sure to hang out for that immediately after this session. Go ahead, Ed.
Okay, hello everyone. So Istvan and I are just going to update you on the latest progress with our lab environment in the Payment Hub EE. Oh, Istvan, you can go next slide. So. Okay, so we're just going to briefly give you some background on Mifos, but I think most of you are familiar with us, touch on a high level on the accomplishments, and then really the main focus is going to be how the Payment Hub can help accelerate adoption of Mojaloop amongst these different levels of institutions. Yeah, and so most of you are familiar with both Istvan and myself, but you can go to the next slide, Istvan. So we're a 501c3 nonprofit that's focused on providing a global open source core banking infrastructure to help bring financial services to the underbanked. Next slide, Istvan. And so I think you're familiar with our team, and you can just refer to this later on. And then just next, I wanted to touch on a high level once again of our vision, bringing together Mifos as an open source core banking account management system, along with Mojaloop as the interoperable digital rail for payments, united by the bridge in the middle, the Payment Hub, which has been the focus of our efforts. And then on top of that, we provide an open banking API, as well as integration with APIs like the GSMA Mobile Money API and Reference App to help demonstrate fintech and third-party use cases. Next slide, Istvan. And so with this, there's 4 APIs at 2 different levels, both at the solution as well as the application level. Next slide. And then we can help enable digital transformation, both within the financial inclusion sector, but also amongst MNOs and banks and others who are looking to become platform providers. And then next slide, Istvan. Yeah, so Istvan's going to touch on the Payment Hub once again, and then I'll jump back in to give you some updates.
Yeah, so the original idea of this Payment Hub was to provide a platform on an open source basis that could be used by the community, besides connecting to Mojaloop, also having the capability to connect to the different account management systems of these institutions, and also provide the capability to the different channels that the bank is having to initiate a payment and initiate a party identified registration, or initiate a request to pay, or initiate a bulk payment. So via these channels, the engine is supposed to orchestrate the process of this whole flow with communications with the Mojaloop payment scheme and the different banking solutions. Potentially what we aiming that create a configurable system that additional connectors could be added easily. So if another scheme comes in, or as we discussed, the cross network feature, this tool could be again handy because it could have another connector to another payment scheme quite easily, and the whole process of a cross network flow can be orchestrated quite nicely using this tool. Yeah, on the technology implementations, it's all the standard stacks, so I hope it's going to be easy for everyone who take this path to utilize. to make sure that we have the clear understanding, because we got a couple of questions in the last months that where is this payment hub fit? So the Mojaloop is the system who makes this whole communication possible across the different DFSPs. But for the different DFSPs, they need a tool to connect to the system. Yes, there are multiple tools now. So we heard just a couple of hours ago the payment manager, then there's an SDK, then there is more tools coming in. So all have different aspects and different capabilities. And our payment hub also coming into the picture at the DFSP to provide that feature that connecting to Mojaloop or other payment schemes and connecting to the accounting systems or the core banking platforms of these banks. And besides having multiple engines potentially running in multiple data centers for a large scale bank operations, it also has an operations interface that the DFSP operators could look into the transaction details and see that what happened and even interact with some of those transactions. So taking a little bit of look inside the engine, what we intend to create or what we provided is a set of microservices running in a Kubernetes cluster inside the DFSP environment. It could be in a cloud or could be on premises. And all of these different components are separated into their own containers, so could be easily modified, could be even replatformed. This whole orchestration engine in the Kubernetes cluster gives the possibility for integrators to use different programming languages for creating their own connectors if that's necessary. And obviously in our solution, we provide a Mojaloop connector. We provide a given banking channel connector that those payments and inquiries can be initiated. And we provide an account management connector, particularly for the Fineract solution. But following this path, any additional account management connector could be added easily. Besides this, we stream all this information via Kafka Stream to put it to an Elasticsearch viable or viewable via Kibana. And also we put it to a long-term transactional database store that the operations staff, after proper authentication, could access this information and could check stock transactions and could search for them and even initiate like a refund for some transactions if that happens. So those features that is provided by the operations application. What we wish to summarize in this session, that based on this engine, in the last couple of months, we enhanced further the account registration process. So now the party identified registration is fully supported with the account management and the Oracle, then further enhance the peer-to-peer or payer-initiated transactions, and now introduce the pay-initiated transactions or request to pay flows into the solution. Then I'm gonna talk about the multi-tenancy features, then all about this user interface, the operational control center, what I was just mentioned, and our lab environment. And yes, we completed the documentation. So anyone now could really get involved, much easier for the setup, for the different repos, to get access to this.
Yeah, and so we're going to mix up the flow of our presentation a little bit this time around. So I'm going to touch on a high level of how the Payment Hub can now be utilized to help institutions at all different levels connect in and participate in level 1 aligned and Mojaloop powered switches. And so right now, as Istvan touched upon, the Payment Hub is production ready. We have our lab environment open, available for others to access. And so right now, the Payment Hub, it is starting to be deployed within our own ecosystem to connect to other payment systems. And it's also being tested out with fintechs like Kanzu Code, but we're very eager now to have it be used in production to help connect with some of the pilots or help connect with some of the production environments and actually moving forward. And the next couple of slides are going to touch on how we can achieve that. So first off, we just want to focus on tier 1 and tier institutions. So one point I wanted to clarify is that to use the Payment Hub, you don't need to use Mifos. It's agnostic to whatever core banking system you're using. It's built with a Mifos connector from the start, but you'd simply need to build to another connector. And secondly, while it simplifies connecting to the Mojaloop APIs, it does much more beyond that. As Istvan will show, we have this operational control center, which allows the DFSP to monitor and respond and take action upon transactions. Istvan's going to touch upon the scalability of it and how it can be deployed across multiple environments. As we touched upon, it's extensible. You can bridge it to other payment systems. You can connect with your channels and other account management systems. And then Istvan's also going to focus on the power of the ZB workflow engine to help orchestrate these microservices end to end, and how you can do this by simply adding additional workers or connecting to the additional connectors that get built into the payment hub. And then one other point we want to emphasize is that it's open source and extensible, and we're eager to have other commercial integrators build upon it. And we want to align with the efforts of Modusbox around the payment manager and make sure we're not duplicating efforts in terms of providing these DFSP level operational controls. And then lastly, there's a roadmap item where Payment Hub could be used for stand-in system capabilities. But I'll pass it back over to Istvan to dive into some of these technical details and some of the progress from the last PI.
And so one concept that needs to be clear, that so this is being a microservice based architecture, could be deployed in multiple ways, cloud or on-premise. That's one dimension. It could be, thanks to its multi-tenant capability, to be a shared service running multiple DFSPs, or like multiple subcodes could be served by a single deployment, or could be dedicated to a single DFSP. And an important aspect, what we try to provide, like different Helm charts or different configurations, that if you want to lean it like a development environment or even production, that you can go with a bare bone installation. Yes, there is no failure protection of the components, but it requires quite minimum hardware to run all the system. Then we can go further to get a medium installation, still like a single Kubernetes cluster, but then redundant of the components on multiple worker nodes, or we could go even further to have a fully scaled system. So for a medium deployment, like this is a potential diagram running multiple of these components, what we are having inside the system. And for a full scale deployment, would suggest like for a tier 1 or 2 institutions, that availability is really super critical, that having multiple independent engines to communicate in multiple data centers and serving the bank or the DFSP requirements. And in this way, we could protect against whole site failures. And even if certain things needs to be upgraded, then our system could still serve the users. Then I wish to touch on the enhancements or accomplishments for this PI event. So the process flow, what we have added. So one of the ones, which is the party identifier registration, let me jump to that one. Okay, looks simple, probably a bit trickier part of this one, that then we register with the Oracle, then we need to handle the error situation. So if the particular identifier already registered, then how we handle it, how we overwrite it, let's say, because now this this party identifier now belongs to this DFSP, and that process needs to be orchestrated. So that's all done inside that connector, which communicates with the Oracle to manage all these interactions. Then a couple of other flows, given the timing, just really highlights that. So this is the request to pay, then the payee initiate this request. So here's the flow and the different steps in it, and how we send the authentication code, and all those necessary interactions. Then on the payer side, who's accepting this request to pay, then depending on the flow, depending on the conditions, do we need authorization, we don't need, how this authorization should be sent out. So there are these white boxes representing that in some cases we need to send out OTP, depending on the DFSP channels to use, and so on and so on. And once this all is completed and all the authorization, right, and then we are ready to do a transfer process. And thanks to ZB and the BPM and capabilities, so this could be extracted to a separate flow. So then I'm ready to do a transfer process. Then here it is. and then I just execute the necessary steps to send the funds over to the other party. And just highlighting some of the boxes here, that in case of problems, no response coming after multiple retries, we have issue with the AMS, and then we could park these transactions and let the operator either manually override that transaction or tell the system that now it's time we fix the particular issue and time to retry those transactions. Then another aspect, so how the operator will see all these transactions and what happens in this control center. So first of all, a couple of concepts that we have now implemented: proper authentication and authorization with privileges. So certain privileges give you access to see the transactions. Others give you access for modifying or actually actioning on those transactions. Another aspect of this whole authentication and authorization, that we support multi-tenancy, meaning that all tenants segregated into a separate database, and separate users, separate operators could access them and interact with their own DFSP's transactions. Yes, there are search screens, there could be refund for a completed transaction if there's an out of the system discussion between the DFSPs. Then there is also this automated attempts which could end up still failing, and then operators could be involved in that solution. Now on this user interface, you could see all these transactions, that incoming, outgoing fund transfers, the request to pays, incoming, outgoing ones, and we're gonna still enhance this further to add the registration to be seen on these screens. Here's an example that I just quickly go through, that there was an incoming payment at a payee with 215 shillings, and that was a completed transaction. So the operator at the payee side could see this transaction, searching for it, then see what happened, then can see the details. This is just partially what the details could show. It gives you more the complete steps and the different values, what you could see. But what I'd like to highlight now, that now an operator, after discussing with the other parties and do the due diligence, could say that yes, this transaction is eligible for a refund, as it was a fraudulent or a mistaken transaction. So specifying or saying that I want this to be refunded, the operator at the payee side could provide some comments, and then the transaction will go back. So I would see an outgoing transaction with the same amount, with 215 shilling, that yeah, it was completed, and it was, if I go to the detail screen, that I could see that what happened inside that transaction. Another aspect that we mentioned, that if the account management system is not available today, what we could do, we could park that transaction in our system and the operators could do something with it. But potentially we could have a stand-in solution that keeps track of all the available accounts. So we could book those transactions here and keep that synchronized with the core banking platform, then it becomes available. If we need to handle only incoming transactions, that's pretty straightforward. If incoming and outgoing to be supported, then obviously the synchronization and providing the necessary steps and running over limits could be a more trickier solution to add.
Yeah, so next up, I just wanted to reflect upon how another category of DFSPs can leverage the payment hub and the entire open source stack to really accelerate their adoption of Mojaloop. So as I touched on earlier, we have our origins from Grameen Foundation. We've got a network of local providers on the ground. So we do have that deployment and domain expertise to help these MFIs and SACOs first, get regulated, digitize their operations, and then connect to level 1 aligned payment systems like Mojaloop. And then if they need their core banking system, they could utilize Mifos hosted in the cloud with a native pre-built integration to the Mojaloop APIs. And then those shared service providers can really leverage multi-tenancy and the economies of scale to reach the hundreds and thousands of small tier 3 and tier 4 institutions that will need to connect in markets like Myanmar and Tanzania And so Istvan is going to talk about how the multi-tenancy can enable connecting these institutions at scale.
Yeah, so the multi-tenancy was another outcome of our development. So the idea here that we have a single deployment, but we want to serve multiple DFSPs. So then the audit logs are separated. So for all regulatory requirements, we could serve these ones, the backups, the archives could be also separated. And we have separate users who could see only their own transaction, which is related to that one, even on that single infrastructure. And obviously the benefits that a single operator could provide service for multiple DFSPs, or if we have a multi-tenant core banking platform like Mifos, then a single payment hub deployment could serve all the tenants configured inside that solution. So here are the two examples that an aggregator model, someone comes up with this payment hub, deploys it, and then we register, let's say, two DFSPs, 1 and 2, for this single payment hub. Yes, it provides multiple endpoints. So for the Mojaloop point of view, this is two separate DFSPs. But behind the scene, we are integrating with multiple core banking platforms. So the necessary models, the BPM and flows, and all the multi-tenant databases and separations happens inside these engines, so we could safely communicate with multiple systems. Or another approach that if someone has already multiple tenants running in the core banking system, which is the case for multiple smaller institutions already, so there are aggregators who are working in this model, then the payment hub could be deployed. And again, for the Mojaloop network, it's like multiple independent DFSPs, but behind the scene, we addressing with the right API calls, the multiple tenants inside the core banking platform, what we have here.
Okay, and then the final category of institution we wanted to focus on how we can help accelerate adoption for are third-party fintechs and PISPs. And you can go to the next slide, Istvan. So you've seen this slide before, but this helps to illustrate the lab environment that we have in place that we think is highly relevant for ongoing efforts like the DFS Lab series of hackathons, as well as efforts with the centralized PISP APIs. So for the fintech audience, we provide these over-the-top APIs as well as reference mobile apps to demonstrate connecting to and initiating transactions through Mojaloop. And then at the level of the DFSP, they can interact with the full core banking API with Mifos and Fineract. And then at the level of the hub in Mojaloop, we have the following use cases that have been integrated with, as well as the ZB workflow engine and the operational control center UI that Istvan demonstrated.
Yep.
And then I just wanted to touch on a few of the updates that we've been making to some of the channel applications and tools here with some of our Google Summer of Code interns during the past PI. So thank you to Vijay and Garrett from the Inclusive Tech Lab at GSMA for helping with the questions our interns had in building out the GSMA mobile money connector. We've been building out the additional ZB workers to add that as a connector and integrate with the different peer-to-peer use cases related to microfinance institutions for our lab environment. And then we have an intern that's also been working on creating a standalone open banking app that's independent of Mifos and leverages the open banking API layer we provide, or any third-party API like the PISP API. And then we've also been continuing to enhance our first-party channel applications like our mobile banking app and our mobile wallet app to integrate with the Mojaloop use cases that are currently supported. And then Istvan's going to go into a little bit more detail about the lab environment itself.
Yeah, I want to be careful with those details because there are plenty, but so what we have in this environment, that we have 3 independent deployments there. So 3 independent DFSP deployments, 2 of them having Mifos 1.x and another one has CN inside. Then in all of these deployments, we have 2 DFSPs in each. So to test the whole multi-tenant behavior and implementation. We have obviously 1 Mojaloop instance to enable all the interactions between the 6 DFSPs. And we also have a fintech application that utilizes the open banking API. So the payment initiation can be started, an account lookup, transaction history can be retrieved using the standard open banking APIs. And yes, we do have CI/CD inside here, so all changes could be deployed quite easily to this environment. So if anyone wishes to join, then join our Slack, and then the environment can be accessed. There are slides to show that where are the different components and how you can connect to this one. This is roughly the high-level diagram. So we have the Mojaloop, then in this Azure environment, we have a barebone, a medium, and a large DFSP. These names refer to the different ways the payment hubs are configured, all of them having API gateways and the core banking platform deployed. And we have a fintech who's able to interact with multiple API gateways following or using the open banking API to access these systems. And if I want to zoom a little bit into the medium platform, that's what we have, and all things connected. So yeah, the payment hub and its all components and the different external access points, as for example these names that the DFSP as the Mojaloop access these components. So the Mojaloop connector, all of them having two endpoints representing the two DFSPs that is provided in this environment. And over here, there's a core banking platform with the necessary additional components of open banking adapters and the API gateway with the WSO2 components to let others connect any third parties to this particular DFSP. And in this environment, as the PISP specifications is getting ready, then would be nice to also enable the PISP APIs, and using the payment hub, I believe also in this environment, the fintechs, being it the small like Google or someone bigger ones, could access this environment, and then they could do transactions over here.
Okay, and then I know we've got about 4 minutes left, so I'm going to quickly run through these slides, but I wanted to touch on like a concept and a movement we're helping to advance that's originated from one of the partners in our Mifos community. Next slide, Istvan. And so this is the OpenG2P framework, and so it's very relevant, I think, given the context of the global pandemic we're all experiencing, as well as the conversations that have been had at this convening relating to identity, biometrics, bulk payments, and etc. But OpenG2P is a number of things, but it originated from the government of Sierra Leone and one of our partners, IDT Labs, in the response that they made to digitize payments to healthcare workers during the Ebola crisis. And then they've been genericizing the components they built there to help address the common challenges that are faced in helping to mobilize, widespread, large-scale cash transfers from governments to persons. So it aims to address these common challenges around, one, digitizing the enrollments, validating beneficiaries, ensuring they're not duplicated, and then the second level of digitizing payments, and then lastly, having recourse mechanisms to actually follow through on the status of these payments. And then next slide, Istvan. And so, as I touched on earlier, first off, it's a framework. It's helping to provide a common understanding of what these challenges are, and then helping to document what these requirements are so people don't reinvent the wheel when trying to build or implement G2P systems. And then it's also a community of practice. So we're trying to build a coalition of supporters of members, a community of users adopting it, and sharing a knowledge base to guide best practices. And then lastly, it is a deployment toolkit. So there is a reference architecture. There are a set of recommended open source building blocks, and there will be a lab environment for it. But these open source building blocks I'll touch on. And next slide. And so this is just at a high level what some of these building blocks are, and we'll skip to the next slide, Istvan. And so okay, and then these are some of the guiding ideals that people can look at, but really, being open source, vendor agnostic, and really allowing the building blocks to be deployed in the specific context of a country, which I'll touch on next. And so this is just a high level, of the overall architecture, looking at the components related to digitizing enrollment, digitizing the payments, managing the accounts, and then digitizing the beneficiary management and recourse. And next slide, Istvan. And so here is just how, you can swap in different open source or different proprietary components for each of the building blocks. So this is more of the implementation that's ongoing in Sierra Leone. So they're using Odoo as the CRM to manage the beneficiaries. They're using Open Data Kit to bring in and collect data. And then they've been using Elasticsearch to help deduplicate the different beneficiaries. And then they're also working with Simprints around biometrics. And then I also wanted to position the ongoing deployment of Mifos at Banco del Bienestar in the context of OpenG2P. Next slide, Istvan. And so here, I just wanted to highlight how with OpenG2P framework, the Banco del Bienestar, they're utilizing Mifos as the actual core banking system to manage and provide an actual account to all of the beneficiaries of the various social programs. And then they'll be exploring using the payment hub as a disbursement engine to disperse payments through the existing Prosa network, as well as SPAY and CODI. And then these will go to Mifos accounts that are accessible via wallets or virtual and physical debit cards. And then I also just wanted to highlight the different sources of ID and other databases that they had to pull from to bring in their beneficiaries. And they've been utilizing ZB to help tie together these microservices. And then lastly, I wanted to close on this about OpenG2P. We're seeking to identify like a reference implementation that could unify these three critical projects. So unifying identity through MOSIP, open source account management through Mifos, and open source payments and interoperability through Mojaloop to really provide this reference architecture for a G2P transfer system. And then
Yep. And another accomplishment that I mentioned earlier, that the documentation is ready for everyone to take a look. So the links are in the presentation in the next couple of slides. So yeah, we include some business overview, and on the technical overview, there's information on the source code repositories, installation instructions. So everything is ready to be utilized, and obviously waiting for feedbacks that what things are there. And a couple of points on the roadmap that we considering, or actually as just heard on Monday or Tuesday, what could be also on the roadmap. So the bulk payment is definitely, as it's getting ready now, we always targeted to do bulk payments using the payment hub, do the pre-processing for those payments. Yes, we need to continue the performance testing and tuning of this application. On the cross-network payments, as we discussed, one capability that we are having, that we did integration with the ISO 20022 payments clearing and settlement messages. So it would be quite easy to do a cross-network POC, switching between the Mojaloop network and the ISO 222 based real-time payment network capabilities. In the PISP, that would be also a potential way to move forward to get the integrated lab environment that the other parties, fintechs, could also join. Then another item that we have on the roadmap to get also the SDK, the Modusbox SDK or Mojaloop SDK to be integrated with the system, and the stand-in capability for larger institutions, another item. And yep, on the bulk payment, the point is that the payment hub could be a preprocessor. So according to the APIs provided, and bridge the gap between the file that the FSP is having and the actual implementation that Mojaloop is providing for these bulk transfers. Yep.
Yeah, I think we ran about 2 minutes long, but these are the links to the docs, the code, and then requesting joining our Slack channel. And I think the point I want to close on is I think a good roadmap item to collectively drive forward on would be more at a generic level of these DFSP operational controls. So looking at components of the payment hub, components of the payment manager, and what are these tools that are necessary at the DFSP level to connect to and interact with Mojaloop switches. So thank you, everyone.
Thanks so much, Edward and Istvan. I appreciate your presentation, as to many others, which your presentation brings us to the end of, I've even lost the count, the end of day 3. I apologize for that. And at this moment, we will ask you all to unmute your videos so that we can see your smiling and very lovely faces. And you can strike a pose like Miguel if you wish to. And we can take a screening. And as we do that, Mela, if you've got any thoughts you want to share, that now would be a good time.
I think I just want to thank everybody for coming. I mean, this is a challenge, of course, trying to do these things virtually. And we were a little bit pressed on time as well. But I think other than that, I think it's been a really good session so far, and I'm looking forward to the breakouts. Thank you for everybody for coming.
Awesome. Thanks so much, Miller. Paula?
Yeah, thanks for everyone for hanging in there. You know, some of you got up real early and some it's getting quite late, but appreciate all the enthusiasm on the chat. I know Simeon will appreciate additional chatter on Discourse. So please do visit there this week and then in ongoing weeks as we build out more knowledge transfer to the community at large. So with that, Simeon, I think we're ready to take those screenies.
Awesome. John, I think you're ready. I think John has already taken the screenies.
Well, I've started, but we still have some folks that have not started your video. So if you haven't started your video, please turn your cameras on. You can do that by clicking the video icon on your control panel. And I'm asking folks that don't, sending you a message right now that says, please start your video. So everybody's screen looks different. So I'm going to start taking pictures right now. So everybody look right at your camera and smile. Take picture number 1 right here. There we go. We'll take another one. Looks like we caught Steve and Haley blinking. Hang on a second.
Wow.
Typical.
One more time. Here we go.
You might be.
Okay, go on to the next page.
Thanks for using those backdrops, folks.
Yeah.
All right, everybody keep smiling. And I'll take a couple here. Okay, there's still a few folks that hadn't turned their video on, but I'm not sure. Maybe they just don't have a camera. So I've got a couple of each. I think we're good to go.
Awesome. Thank you so much, everybody. I put in the chat box a link to all the sessions for Discourse. Please hop on there and add your comments. I'm very grateful for everybody who's been actively engaging people there. That's awesome. We will see you tomorrow, 11 a.m. UTC for more technical updates and proof of concept presentations. Have a good one, everybody.
Good night.
Cheers.
Cheers.
Bye. Bye.
All right.
Bye.
Cheers.
Cheers. Bye, guys.
Bye.
Some folks just don't want to leave.